In this video, we'll look at the half-angle formulas. So we'll kind of do what we have been doing. We'll do a quick review of what we've learned up to this point. I'll prove for you one of the half-angle formulas. I'll give you all of the half-angle formulas, and then we'll look at an example. So the double angle formulas, I'm just going to keep driving this home. Remember, these are really important, and we get these from the addition formulas for sine and cosine. The formulas for lowering powers, remember we just solved for sine squared x, cosine squared x from our double angle formulas. And tangent squared x we can just derive simply by dividing the formula for cosine squared x into the formula for sine squared x. So now we are going to write a new formula for half angle formula. And to do that, we'll start with a formula to lower the power. So let's begin with, let's do it with sine. Let's do it with sine. So we start with sine squared of x, that equals 1 minus cosine 2x over 2. So now let's just say, let's let x equal u over 2. So now we have sine squared u over 2 equals 1 minus cosine 2 times u over 2 all over 2. So these 2's cancel. There and there. So we're left with 1 minus cosine u over 2. Now if we just take the square root of both sides, we have sine of u over 2 equals plus or minus the square root of 1 minus cosine u over 2. Now you may be thinking that I'm doing some like weird mathematical wizardry here, but this is a completely valid method. All we're saying right here is that there's this relationship between the x inside the sine squared and the x inside the cosine. And so if we make x equal to u over 2, something divided by 2, then we can make what's inside of the cosine just be the variable. So it's completely valid, and really it's just a way of showing that there's this other relationship going on within the formula to lower power. And where we end up with is we end up with sine of u over 2 equals plus or minus the square root of 1 minus cosine u over 2, where we choose positive or negative depending on the quadrant in which u over 2 lies. So we have the half-angle formulas are sine of u over 2 equals plus or minus the square root of 1 minus cosine u over 2. Cosine u over 2 equals plus or minus the square root of 1 plus cosine u over 2. And tangent u over 2 equals 1 minus cosine u over sine u, or sine u over 1 minus cosine u. You choose positive or negative depending on the quadrant in which u over 2 lies. So perhaps one of the more obvious ways that we can use these formulas is if we want to find the exact value of sine 22.5 degrees. The first thing we notice is that 22.5 degrees is just half of 45 degrees. So now we can use our half angle formula. So we can say that sine of 45 degrees over 2 equals the square root of 1 minus cosine 45 degrees over 2. Now the question is, what do we put here? Do we choose positive or negative? We'll choose the positive one since 22.5 degrees is in the first quadrant. So that's a pretty easy one. Remember, that would give us a positive y value. So now we can just evaluate the square root of 1 minus cosine of 45 degrees is root 2 over 2, root 2 over 2 all over 2, which, in other words, this gives us the square root of 2 minus root 2 over 4, or 1/2 the square root of 2 minus the square root of 2. So that is the exact value of sine 22.5 degrees. In the next video, we'll use the knowledge that we've built up to this point to do more evaluating of expressions involving inverse trigonometric functions.